Welcome to the Sports Science Dudes. I'm your host, Dr. Jose Antonio, and my special guest today is Kristi Storoschuk. She's a PhD candidate in muscle physiology in the muscle physiology lab at Queen's University in Ontario. Her research focuses on exercise, metabolism, and skeletal muscle adaptations, which, by the way, that's how I started way back in my career, just so you know. Specifically, her research explores how exercise and nutrition interacts to influence metabolism and adaptations to high-intensity exercise. When she's not in the lab, you'll find her in some sort of adventure in the woods, which is kind of cool, working on your garden or training in your garage gym. Now, there was something interesting that I read your bio online, and you had said originally you wanted to be an ND, a naturopathic doctor, which it's weird to go from that, in my opinion, to going to just now you're doing basic science research. And a lot of people also don't know you played D1 volleyball at Weber State. So you're actually more of a strength power type athlete. Is that correct, Kristi?
Honestly, I don't even identify as an athlete in general. So that feels like a very past life of mine. But thank you for resurfacing that.
Well, it wasn't that long ago, was it?
It
I
feels
mean,
like a long time ago, but I guess not.
well, I think if we all train, we're athletes sort of in our own way. I mean, down in South Florida, we do a lot of paddling, stand-up paddling, outrigger canoe paddling. And I pretend I'm an athlete. I enter races. So if I'm racing, I'm a bit of an athlete. So, but tell a little bit, this idea of you were interested in naturopathic medicine. There must have been a light bulb that turned on in your head. And you're like, I think I like this research stuff better because it is quite a change. So explain that sort of evolution.
Yeah, well, first off, I want to just say thank you for inviting me on the show, and it's
Oh,
really
you're welcome.
a pleasure to be here and to be chatting with you today. But yeah, so I grew up in like the natural health world because my grandparents owned a supplement store or like a natural health food store, and so I just always thought that that's the path I was going to take. And I met a lot of NDs growing up as like a young teenager, so I thought, oh, that looks like a great career. I'm gonna just go into that, set up my university so that I can get into naturopathic college. So that actually, so I left high school on a D1 scholarship to Weber State, which they had a pre-natural medicine undergrad
Which
program.
is unusual. That's not common.
Yeah, so unusual. I thought I was just going to go into pre-med. And but it was under the botany department. So
Oh, wow.
I was in plant science, and then I actually ended up transferring from Weber State and finishing my degree at the University of Guelph in Ontario. And in order to find a school, I transferred to Guelph because I was essentially the only school that had a botany department that I could transfer my courses to.
Wow,
Um,
botany. Yeah,
so
just before you go on, that was the only course I did poorly in as an undergrad. Botany killed me because I was like, I cannot memorize all these plants. There's way too many plants. But anyway, sorry about that.
Um, and so anyways, like because I wanted to become an ND, I ended up in a plant science degree. So that was my undergrad degree. And then I ended up, but my interests have always been human health and applying lifestyle to improve human health from a very young age. So I still feel like even though I'm in a drastically different field, I still feel like I'm on the same path. But finishing up my degree, I started within my third and fourth year courses. That's when we do a lot more experimental stuff in the lab because I was in a science degree, so I was in the lab a lot with my
Mhm.
courses. And I realized that I actually liked doing science and I thought it was cool using these tools to and asking questions and then getting answers out of it. So I started reaching out to different professors who were studying the ketogenic diet. That was my initial interest when I decided, okay, I'm not going to go to naturopathic college. I want to go into research. And I was really interested by ketones because it was the only diet that induced a state with a molecule we could follow, and it had signaling properties, and it was a way to track adherence to a diet, unlike other diets like paleo, vegan, Mediterranean. You don't really know if they're adhering, we're just taking their word for it. Whereas
Right.
a ketogenic diet, we know if they're adhering because they're either in ketosis or they're not.
Right.
So I ended up actually working under Dominic D'Agostino out of USF there in Tampa, and I was just working for him, doing science communication. I was in the lab a bit, but just as a volunteer, I got to do a bit of research with them, get my toes wet with research, and kind of rode that wave for a few years until I was like, okay. My intentions were to go back to school, and now I just ended up working in science communication. So eventually ended up in the lab that I am here at Queen's University in Kingston, Ontario. And I'm in a muscle physiology lab because I was interested in mitochondria and knowing the links between mitochondrial health and metabolic health. I really wanted to study mitochondria. So that's how I ended up in an exercise physiology PhD program, just based on like one thing led to the other, but I still feel like it's one very aligned path,
Yeah.
but very different for different areas.
Well, that's interesting. Actually, I had a position very briefly at the University of Delaware for muscle physiology. That actually was my initial background. My PhD was actually in skeletal muscle physiology because, like you, I was interested in the basic science of it,
Mhm.
mostly from a hypertrophy and hyperplasia standpoint. But I always loved sports nutrition and supplementation and looking at questions related to that. And this is really what prompted me to seek you in terms of that recent paper that you had published. And it really is, there's a lot of interest as it relates to um, zone two, the different zones of aerobic training, et cetera, et cetera. I want to ask really sort of a broad-based question. When you look at sort of the steady state aerobic training, and let's call it zone two. I mean, to me, zone three is steady state too, but let's say zone two. And differentiating that from high intensity interval training or sprint interval training. The big questions that I get from students would be, is there a difference in terms of the adaptive response quantitatively, meaning does one elicit a better response, but qualitatively it's the same? And for example, mitochondrial volume density, does it go up more with one type of training versus the other? Are we talking about untrained people, highly trained people? So there's a lot of noise there. So if you could sort of sift through the noise and tell the audience about, interval training versus, I guess, steady state.
Yeah, and I don't know if you'll love my answer just because we don't like it depends on how we're measuring. So that I was always confused about this too. Like, could you increase function without changing content or vice versa? Or because realistically, they should just all increase in parallel. And that's kind of how physiology works too. It's like we're adapting to stress. We're not just increasing mitochondria without improving like cardiac output or something like that. Like
Right.
we need to deliver oxygen to the end point being mitochondria, but we study things in silos, so we don't think of things as a whole body physiology.
Right.
That's besides the point. So first off, just like explaining the differences between the modalities of intensity and exercise. So HIIT and sprint interval training, like those are such high intensities that we just can't sustain them for durations that would count as steady state exercise. So we have to incorporate those intervals, so those rest periods, so that we can do it again.
Right.
Whereas steady state exercise, essentially, we should be able to work up to like critical power or our maximal lactate steady state, whatever you want to define that demarcation, where as soon as we work out above it, it's very difficult to sustain. And as we keep increasing, then that's where we would technically have to just do intervals if we wanted to
Right.
get to those intensities. But when it comes to mitochondrial content versus function, and I want to say like I I haven't studied this question like specifically, but based on the meta-analyses that I have been familiar with, we would think that there's a minimum intensity. So there was a meta-analysis of about 56 training studies that suggests that a minimum intensity for which increasing volume either through increasing intensity or increasing duration, we would get greater increases in mitochondrial content and mitochondrial respiration. But there might be a minimum intensity for which and the answer might be that we just need to accumulate volume above that. So like I said,
Mhm.
either by increasing intensity or by increasing duration of that steady state. But there are a lot of studies that just show similar outcomes with MICT, so moderate intensity continuous training, which I would argue in most studies is above zone 2. So like you said, like there's zone 2, but then there's zone 3. But I think that zone 2 might fall below that minimum intensity, and
Right.
for which we would want to just accumulate volume above to increase both mitochondrial respiration and so respiratory capacity, so the ability to use oxygen and generate ATP through mitochondrial oxidative metabolism.
Sort of, sorry, sort of the pragmatic question is, if someone said, what if I just did a lot of volume of zone 1 and 2? Let's say they like to hike, but they
Yeah.
hike for hours versus, do I really need to do interval training to achieve the same ends? Whereas I could just go out in the woods and hike for 2 to 3 hours a day. The answer might be we don't know, but sort of speculate on that.
Yeah, so I guess my answer would be that you'd probably get similar benefits to doing HIIT as you would moderate intensity continuous training, with the caveat that there might be a minimum intensity for which accumulating volume. So a long duration of steady state exercise, you might want to be in this zone 3 to 4 before reaching those high intensities where intervals would take place. So I think, yes, like I think there's many options to getting improvements in mitochondrial content and respiratory capacity, which is what we use to define mitochondrial capacity. Because a
Right.
lot of these terms are a bit hand wavy, but for the sake of our conversation, mitochondrial capacity just kind of encompasses content and function. But you might like there are some studies that show only sprint interval training improves respiratory capacity and not content. But it might just be due to like measurement, the way that we're measuring these things. I think just consistency, frequency of training, making sure we are accumulating volume above zone 2. Like I don't want to say this, but like at a higher heart rate than would be zone 2,
Right.
whether that's accomplishing that through intervals or through moderate intensity continuous training. I think you could get to the same endpoint by accumulating volume.
Explain to the audience, because they may not be familiar with the different zones, how that's defined in the literature.
Yeah, and so the way that the zones that we talk about in exercise physiology kind of are different from just endurance training conversations, where that in endurance training there might be 5 to 7 zones that are discussed. But the way I understand zones or different categories of intensities are based on these domains. So, and there's 3 of them. There's a moderate intensity domain, heavy intensity domain, and severe. And there's been recent arguments for a 4th, which I actually forget what the term is for it, but it's above severe. um, and so zone 2 comes from the endurance training world that would fall right. So the way that those 3 domains are differentiated is based on gas exchange thresholds, but also lactate threshold, which that's what people typically use to define these zones, especially within the endurance training world. So zone 2 falls right before lactate threshold 1, and that's also what demarcates the moderate intensity domain from the heavy intensity domain. And then within the heavy intensity domain would be zones 3 and 4. And then as soon as you get into the severe intensity domain, that would be 5, 6, whatever, whoever you're talking to based on whatever they think. But zone 2 is pretty, it's consistent among no matter how many zones you're talking about. Zone 2 falls below the moderate intensity domain, just below lactate threshold 1. And so if we're talking about moderate intensity continuous training, you can do long durations so you could do hour to 2 hours within the heavy intensity domain, and that wouldn't be classified as zone 2, but it's still steady state exercise.
Right. Yeah, I think a lot of people conflate all steady state with zone 2.
Right.
And there are individuals who could do some pretty high intensity steady state for quite a long time. I mean, 1 hour or an hour and a half or whatnot. Now, if someone were to ask, and I guess this is where it gets a little confusing, most of the literature on training is sort of, you have baseline and then you measure some sort of adaptive response 6 weeks later, 10 weeks later, or whatnot. And then you have issues with, you're looking at untrained people for the most part in these training studies, or people who are, I call them recreationally trained. I mean, they're willing to be in a study to do, HIIT or whatever. But then you have issues of, well, there are people who've been training for 20 years. So does any of this apply to them? I mean, my usual answer is no. I say, well, no, because there's no 20-year studies. And also, by the time someone's been training for 20 years, these issues of whether to do zone 2 or 3 or do high intensity interval training, now I think you're getting into more the art. I call it the art and science of training, because you're never going to get a 20-year study. So I guess the question is, reconcile sort of the short-term data, a lot of it on untrained or moderately trained people, with those of us who work with people who are actually highly trained.
So my interpretation of the literature is that the more trained you are, the more you require intensity to induce adaptation, which contradicts the messaging, because it's usually like, oh, you want to be an athlete, you got to do lots of zone 2, which it's like, wait, no, but the literature would suggest that you actually require that intensity to keep on adapting. It's kind of like resistance training, like progressive overload. Like our
Right.
aerobic system wants that progressive overload to adapt and become bigger, better, stronger, so they can handle that aerobic challenge again in the future, similar to how our muscles grow and get stronger. So it is interesting when we think about the messaging based on populations, because the people who might adapt to zone 2 are actually the less trained individuals, where they go from nothing to something and they adapt and they get better. And I want to disclaim and say this right off the bat, in that, like, I don't think zone 2 is like a waste of time or useless. I just don't believe that it's doing what we think it's doing, or the way that it's promoted is people are buying into a mechanism that we have no real strong evidence to support. And I don't even come from this as like an anti zone 2. It's more just correcting misinformation and
Right.
making sure that we're understanding why we're doing what we're doing, not based on false messaging or claims that we're reading through social media.
Yeah, I think the biggest claim on social media has to do with zone 2 and longevity. Peter Attia and Andrew Huberman, I mean, they've actually videoed themselves, I believe, saying, hey, I'm doing zone 2 training and this is what you do to live longer. And to be honest, I don't even know how you can make that claim when, one, it presumes, and they're using it based on heart rate. How you would know that when the longevity data really is, well, people who are active live longer than those who are not. And people who lift weights live longer than those who are not. And people who lift weights are not doing zone anything. And in fact, I think amongst Olympic athletes, the ones who tend to live the longest are the ones who play racket sports. They're not doing zone anything. So comment a little bit on that. The sort of the notion that zone 2 is what, the data on it shows that if you want to live longer, it's zone 2.
Right. And so I think the messaging really revolves around the importance of being able to burn fat efficiently. So our metabolic flexibility, so responding to insulin, responding to different scenarios like rest to exercise, where we need to increase fat oxidation. We know that that's blunted in those who are metabolically impaired. And so I'm under the impression that the idea is that zone 2 improves our fat oxidative capacity, our mitochondria, which our mitochondria are pertinent for. So zone 2 promoted for improving mitochondrial capacity, thereby supporting greater fat oxidative capacity, and thereby supporting better metabolic health, because it's just improving our metabolism. And so that's basically where I come at this, is those messages around it. And because it's improving our metabolic health, thereby it's promoting reduced risk of mortality and thus longevity. That's kind of my storyline that I interpret. Do you agree with that?
Well, I think that, well, then you could argue that the higher intensity zones also do the same thing. So,
Well, exactly.
I mean, so,
But I wanted to
so
get the story straight before we
right.
move forward.
So it's not actually zone two, it's any zone that requires either sustained activity or just intervals. So you could claim zone two, zone three will improve longevity. Hell, you could claim that doing no aerobic training will improve longevity if you look at the observational data on longevity, it's basically if you're active, you live longer. It doesn't say you got to lift weights, it doesn't say you got to run, it doesn't say you got to swim. It just says those who sit a lot don't live as long as those who move. And again, that could be, if we're talking longevity, that could be this person who just likes to go out for a walk. It
Yeah,
sounds silly, but and that I think that's where people, I guess people get, I don't know if they get confused. We're talking about the average consumer where they hear all these messages and it's like, well, zone two, well, but I like to lift weights and I really don't like to do aerobic training, but people who lift weights also do better. So in a way, you're deceiving the general public about, longevity. And again, what the problem with studying longevity is what's the clinical endpoint? It's death, which you can't really study clinically. It's like, okay, well, let's see who lives the longest.
well,
So
yeah. So, like, we know that VO2 max is a strong predictor of all-cause mortality and disease risk. And so, if we think about VO2 max over the claims around mitochondrial improvements and fat oxidative capacity, we have much stronger evidence to show that VO2 max is a much better predictor of our overall mortality risk. And we have also strong evidence to suggest that intensity is an important driver of improvements in VO2 max. So
right.
if I were gonna say like, oh, what type of exercise should I do if I want to improve my lifespan and
Mhm.
health span, I would want to improve my VO2 max, which means that I would want to prioritize intensity. So that's just another contradicting message within the zone two stuff. And I don't think anyone is promoting zone two for improving VO2 max. I don't think that's the messaging around it. It's that we should be doing high intensity interval training for VO2 max, and then we should be doing zone two for our mitochondrial content, our mitochondrial capacity, and our fat oxidative capacity, and that they're doing divergent things and that we need both. But my pushback is that like I don't see strong evidence for needing zone two in order to improve mitochondrial health and fat oxidative capacity. So you can improve your VO2. These things usually work in concert in that we're supporting a higher VO2 max because we're supporting greater oxidative capacity, which means that we're supporting mitochondrial capacity and fat oxidative.
Right. Now, let me ask you this. So, diving from looking at mitochondrial capacity to performance, can you run faster or swim faster? So you have athletes, let's say they've been training since they were little kids, and now they're in their 20s, and they compete in a podium sport, the run, bike, swim sports. There's data on high-end athletes. In general, it seems like most of their training tends to be steady state training. I won't use zone two because I'm sure their steady state is still pretty intense, but they can do steady state training. And it's upwards of roughly, and this is Steve Seiler's work, 80% steady state, 20% interval training. And that seems to be common across several disciplines in the endurance world, whether it's run, bike, row, swim, et cetera, et cetera. So looking at performance, forget issues of mitochondrial volume or density or oxidative metabolism. What advice would you give someone, let's say, who's in high school and is a runner and wants to run, let's say he's a cross-country runner. So let's say he does the 5,000 or maybe they do the 8,000, 8K cross-country. In terms of how do you titrate steady state training, whether you call it zone two or three, versus interval training?
Okay, I'm not addressing performance with the research
I
that
know. I want you to speculate though, based on the basic science.
um I also just want to discuss too, like, so there is the 80-20, and athletes do perform, high-level athletes perform a ton of zone two training, supposedly. But they also perform a ton of high intensity training. Like the amount of high intensity training that they do would be probably just a normal person's weekly high intensity or more than what someone if they're actually following a HIIT
It
protocol.
would kill most of us, basically.
Yeah. So we have this huge amount of low intensity exercise that they're performing, and then this small duration of or volume of high intensity training that we're doing, but then we're attributing their really good performance and their high mitochondrial content, etc., to this large volume of zone 2 training when all the basic science, like you said, would suggest that it's all those adaptations are actually driven through that small 20% of high intensity interval training or whatever, a volume accumulated at higher intensities. And we don't really know what that zone 2 is doing. So I know that you wanted to discuss like what evidence do we have for zone 2 training? And I would say that we don't have a lot of evidence for zone 2 training supporting these outcomes that we think it's supporting. We just have this correlation data and a lot of it that high level athletes do a lot of zone 2 and they also are really good athletes. So we're taking that and then we're attributing their good performance to that 80% and then trying to apply it to the general public, which that's where what our paper addresses. But back to your speculation, again, not a performance researcher, haven't dug into necessarily the types of training protocols for endurance performance. But my main message, and this is for general public and just based on what adaptations we're trying to achieve, is that we just want to accumulate as much volume above zone 2, essentially, that we can recover from. So why athletes do a lot of zone 2, we don't know. There's definitely some pretty good rational reasons why they do it. That probably there's truth within them all, and I don't necessarily want to get into it because I don't know. But I do know that all the research that we have on training studies that would suggest that we just want to accumulate volume above zone 2, so zone 3 plus, and then high intensity and sprint interval training might have some unique benefits, or it's just that we can use them to save time. They're more you get a better bang for your buck if we're working out at higher intensities. You could actually get away with a little less volume. But we need to, I don't know what the threshold is, but at some point, too much intensity is going to increase the risk of overtraining,
Yeah.
relative energy deficiency syndrome. So like different, we don't want to get to that to experience symptoms of overreaching, and we want to be able to recover. So I've kind of just phrased it in my head as volume accumulated over zone 2 that is recoverable. So whatever that is for an individual, it might be just a case by case. But if you find that you're doing too much, that you can't go out and perform the next day or the next day, and you just need a lot of recovery days, then you're probably pushing yourself too hard. And in that case, instead of maybe taking a rest day, you benefit maybe psychologically, but possibly physiologically from doing zone 2. So I kind of also parallel this to how you would formulate a diet. Like I'm sure you're on the same page where it's like, okay, you figure out your calories, you figure out your protein, and then you let fat and carbohydrates fall in place wherever they land
Yeah.
within your caloric budget. I think of it as like, okay, figure out how much high intensity exercise you can do, what's that volume, and then you just let the other fall into place at low intensities, and that would be zone 1, zone 2. But it's about if you have the high intensity in place, that should be driving the outcomes that you're looking for. And similar to a diet, it's like protein calories are in place, then that should get you to your end goal that you're trying to get to. And like I said, that would just depend individual to individual. If you're able to recovery, I think is getting a lot more attention. So sleep, nutrition. If you're under fueling, you're not going to be recovering properly, and that carbs and protein are obviously going to be very important. Again, I don't study sports nutrition, but if you're trying to maximize your recoverable amount of volume at intensity, then you're going to have to pay attention to nutrition, sleep, etc. And then any more exercise that you want to do on top of the amount that you can tolerate at higher intensities, then that's when you would supplement in with some zone 2.
Yeah, my experience working with high-end athletes is there are some who could do quite a bit of high-intensity interval training. My wife, actually, she's a competitive cyclist, and I see her training, and it's 55% interval training, which is like, that would kill me. And then, I work with some stand-up paddlers here. They're actually world class, and I don't know if they actually do any low-intensity stuff, which sounds weird. But they recover. So it's sort of like, well, you recover. And maybe because it's non-impact, like cycling's non-impact, paddling's non-impact, that it's just different when you compare it to a sport like running, because obviously running is just much harder to recover from. And so when I know you're not someone who looks at performance per se, but a lot of this sort of ties in.
Yeah.
Remember, there was I forget what country he's from, an Olympian probably 80 years ago, Emil Zatopek. He was a 5,000 and 10,000 guy. And he had pretty simple idea of training. He said, I already know how to run slow. I just need how to learn how to run fast. And so he was one of the first to actually do intervals. He's like, the only way to learn how to run fast is to run fast. So his training was just crazy. So so I guess give us sort of the paper. I read the paper. It's very interesting. And most people who are in the personal training world will try to take something pragmatic out of it, because at the end of the day, I'm in a field that, even though I like the science, everyone wants advice, right?
Right.
Like, just give me advice. So what would you tell the average personal trainer or sports dietitian that works with athletes? What would you tell them is sort of the best summary of your paper?
Yeah, I would say that because the messaging just does almost convince you that you need to do zone 2 training if you want those outcomes that they're promoting, I would say that you don't need zone 2 training. If you enjoy zone 2 training, totally do it. But if you're doing it in place of higher intensities that you enjoy, prioritize intensity. All the research that we are aware of would support the use of higher intensities for promoting not only greater adaptations to exercise, but also overall health. So don't be convinced that you need zone 2 training based on the messaging on social media, and accumulate as much recoverable volume as you can above zone 2. I actually think that because we looked at this very mechanistically, like the way we understand adaptations to exercise. So what are the signals within the muscle that essentially turn on signaling pathways, and then the actual outcome. So we addressed those three, I guess, areas with zone 2 training, and all of the evidence would suggest that intensity drives the signals, intensity drives the signaling responses, and then the outcomes we have less, because it's easier to do just those acute studies. We don't have as much research to show that the outcomes, but intensity, it's still, meta-analyses would suggest that intensity is driving those outcomes that we're looking for. So anything steady state exercise within the heavy intensity domain, which is above zone 2, or intervals, whatever you prefer, it's just getting increasing the volume, and intensity might play a part in having unique benefits, like I said originally. But my pragmatic advice is prioritize intensity, and if you can do more, do more. But if you can't recover from it, then you've probably reached your threshold.
Makes perfect sense. Hey, can we talk about fasting?
Yeah.
Yeah, there's the paper you sent me. One of the questions I had, because I'm not familiar with the fasting data, so you're gonna have to educate myself and the audience, that there's a different response in rodent versus human skeletal muscle. And sort of explain that and why it should differ, because I've also used rodent models. This is way back, rodent models and actually bird models, believe it or not, to study muscle hypertrophy. And the response is actually similar between rodents and humans, and even birds, to be honest, to some extent. So why would this be different between rodents and humans?
Yeah, and a little backstory, it's honestly, it so parallels this zone 2 paper as well, because it's me consuming things on social media and then bringing it to my supervisor and being like, "Oh, let's study this," and him being like, "That doesn't make sense."
That's great.
So this
Hey, you
one,
know what? A lot of great ideas come out of social media, mainly because it's like, I don't know if I agree with that. And then you decide I want to study it.
right, exactly. Because I initially, my PhD was going to be related to fasting, and then I was just kind of like, oh, wait, it's not doing anything. So the idea behind that publication in 2023 was that I was under the impression that fasting is this energetic stress. It therefore should induce pathways that respond to energetic stress, improve metabolic flexibility, which I bring back, which I get a bunch of crap for from our other supervisor, Dr. Chris Muglori, who thinks that there's no definition to metabolic flexibility. So I understand that metabolic flexibility is a bit of a hand wavy term. So
Actually, no, I'm glad you brought that up. Is there an actual definition for it?
I think that like Kelly and I can't remember, I don't know his or her first name, but the original research with metabolic flexibility was really just our ability to respond from rest to exercise. So we should be able to, our RER should reflect increased fat
Right.
oxidation in response to increasing energy expenditure. And then we should be able to respond to insulin. Um, and and so that would be one end of the spectrum, insulin sensitivity, and then the other end of the spectrum being fat oxidative capacity. And if both of those are responding appropriately, then we are therefore metabolically flexible in that we can turn on the pathways and necessary processes to energy demands depending on the situation at hand,
Right.
substrate use, the appropriate substrate use. So I mean, even me just rambling there just goes to show like maybe we don't have a clear definition, but that there is different tools we can use to measure it. Um, anyways,
Right. Yeah.
my back to what I was getting at is that fasting online was being promoted as a way to improve metabolic flexibility because it gets us into this fat burning zone. We're depleting glycogen, therefore flipping on that metabolic switch. And now we might be burning fats and ketones and going back and forth between glucose and fat oxidation. That's improving our metabolic flexibility. And I put that in quotation. That was kind of the idea. And if we're improving, and this is all based on supporting better mitochondrial health. And again, because we're in a mitochondrial lab, I was like, oh, well, if fasting is improving mitochondria and thereby supporting better metabolic flexibility, I want to study fasting. And then started looking into the research. And we are a mechanistic lab, we're a molecular lab. So when it comes to if we think about mitochondria, we always have to think about, okay, well, the signaling that we would study, that we would be able to infer induces mitochondrial adaptations, what kind of interventions essentially turn on those signals so that we can study it. And my supervisor had past students run fasting studies for 8 hours, so that was a short-term fast, and then up to 48 hours. And one of the mechanisms, one of the signaling pathways, well, the primary signaling pathway that we study in our lab is the AMPK PGC1 alpha axis, which AMPK responds to energetic stress. So as we're turning over ATP, if we do that at high flux, so think about high intensity exercise, we're turning over ATP. Our requirements for ATP is very high. We start accumulating AMP, and ADP, and those are the signals that turn on AMPK. Once AMPK is activated, it phosphorylates PGC1 alpha, which is a purported like the master regulator of mitochondrial biogenesis. So essentially, if this pathway is turned on, we expect mitochondrial biogenesis to be activated.
Right.
And so I was under the impression that fasting was this energetic stress that should be turning on this pathway. And so that's why I wanted to study it. However, it turned out that we didn't have human evidence supporting the use of fasting up to like 72 hours. So long-term fasting, you would think is an energetic stress, but these pathways aren't activated, which shows that it's not an energetic stress. So I ran a systematic review. We screened thousands of studies. We extracted data from hundreds of studies. We ended up with this data set of I have 47 data points from mice, rodents, and humans,
Hmm.
and looking at these mitochondrial outcomes. So AMPK activation, PGC1 alpha activation. And essentially, we found that, yeah, it's turns on in mice and in rats, although it's inconsistent, more inconsistent than we thought it was going to be. But we essentially had no evidence that this pathway is being turned on in humans. And it was even within like really good journals like New England Journal of Medicine and other like high impact journals where you would find reviews and figures with this with pathways that would start with fasting or caloric restriction, leading to the activation of AMPK, leading to the activation of PGC1 alpha, leading to mitochondrial biogenesis. And I was seeing these types of figures all over the nutrition and metabolism literature. So like, I'm obviously going to think like, oh yeah, fasting activates this pathway. But we're just all of those figures, I guess, were just based on rodent data. And my analysis showed that we actually have no evidence that this is happening in humans. So we can't say that fasting is activating mitochondrial biogenesis through these pathways and thereby supporting better health. Because it's all just based on rodent data. And in the paper, we speculate why we might be seeing these differences. And it most likely just comes down to the differences in metabolic rate. So fasting, um, mice lose like, I think it's like 50% of their body weight or some
Oh my
like
God.
crazy amount. I might actually be exaggerating that. I can't remember. I'll just say a crazy amount of body weight in like 24 hours, and humans lose like 1%. Um, and
I
they
mean, it makes
also,
sense. Their lifespan is so short that they would lose that much.
right, right.
Yeah.
And so one of the activation, like one link to mitochondrial biogenesis is glycogen depletion. And mice and rats actually deplete muscle glycogen really rapidly in response to fasting, whereas humans don't. We don't, our muscles are happily humming and hawing on fat oxidation without incurring any sort of metabolic stress because we have fuel available. We're not at an intensity that like sitting at rest fasting is not depleting muscle glycogen because there's no demand on the muscle to burn carbohydrates. We're burning fat, and that is our preferred fuel at rest is fat. So we don't burn any glycogen up even up to 72 hours. If we're fasting, we're actually not emptying our glycogen stores in our muscles. We are in our liver, and that makes sense. We're trying to maintain normal glycemia. But our muscles don't contribute to blood glucose, so we're not ever breaking down glycogen and putting glucose into the bloodstream. So that's another reason why we think we're seeing differences in rodents and in humans. And then it's just characteristically different. Like we're in different environments. Mice actually end up moving more when they're fasting, so maybe that's why they're
Hmm.
burning glycogen because they end up like trying to forage and or
Interesting.
they're also housed at different temperatures that might influence their metabolic rates. But humans actually become more sedentary when they fast. I mean, unless we're deliberately overriding that by saying I'm going to work out when I fast or something. But if we're just living free living and we are fasting, we actually end up just like taking less steps throughout the day or just sitting more. We increase our sedentary time. So that also might explain differences in rodents and in humans. But end of the story is that the fasting effect in skeletal muscle is radically different in rodents than it is in humans, and we can't be attributing um, a benefit of fasting to what's happening to the health of our mitochondria and saying that that's supporting better metabolic health. And this isn't to say, again, similar to the zone two, it's not that fasting's useless. I think fasting is actually a great tool, especially time restricted eating or intermittent fasting. If it gets you to a caloric deficit and like weight loss is supporting the better health outcomes, then I do believe there are applications for fasting. But where I take issue, similar to the zone two and similar to the fasting, is that we're just giving something a mechanism that people can't even test. So we're just like convincing the public with mechanisms that they have to just put faith into. And then it's changing behaviors based on mechanisms that actually we don't have evidence for. And I think that that's just like the general theme is that there's just misinformation. And it's changing behaviors. And I think that's really important because if it's changing, well, not even on an individual basis. So the things with zone 2 is influencing clinical practice. So if we're now prescribing certain things to our patients because we're seeing this type of messaging that sounds all scientific and it tells a good storyline. I just think that I mean, I think everyone would agree with me that that's an issue. We're not staying evidence-based, and when we're talking about human health and just empowering individuals to take their health into their own hands, making things complicated is not the answer. Like of course, we can give protocols and we can give people structured plans, but you can do that in a way that also acknowledges that there's several other alternatives and maybe one's better than another, but maybe for another person, the other thing is better for them. Like there's lots of alternatives to improving health. And so that I think I'm just bringing this up because that was the motivation behind both the zone 2 review and this fasting review is that I was led to believe one thing and then science told me another. So
Well, I always say many roads lead to Rome, so there's more than one way to do things. And I think what's interesting about the rodent versus human data is certainly in the sort of sports nutrition, human performance world, a lot of people have gotten to the point where they just ignore rodent data now. It's because whether or not it applies to the human condition, more often than not, especially in nutrition, it doesn't. So there's a lot of people who just they don't care about rodent data. And in a way, I've gotten to that point with some of the sports nutrition stuff. And it's not because I don't like animal data. For my PhD and postdoc, I had experience with cat models, rat models, bird models, guinea pig, even worked with fish, believe it or not, for a short period of time. So I'm very much aware of what's great about animal models. You can control everything. What's bad about it is, well, they're animals. So there are trade-offs to everything. Now, earlier you said you might have your PhD in less than a year, hopefully half a year. So tell the audience what you're working on now, what project you are, and then I want to talk a little bit offline, because I wanted to pick your brain a little.
All right. Well, I'm about halfway through data collection of my final study. And this one's in collaboration with Dr. Andy Galpin and Dr. Tommy Wood. So we're validating a blood-based biomarker or signature of muscle quality that Tommy has developed with another student. And my job is essentially to take biopsies in blood from individuals and validate whether this blood-based signature predicts their muscle quality using actual muscle tissue because the model was designed in population-based data. And then I'm taking a part of this project towards my PhD thesis and looking at whether zone 2, so lactate threshold, whether that is a functional test basically to predict or tell us about mitochondrial content. So can we use a lactate threshold test to infer mitochondrial content, essentially what I'm looking at, across different ages, across different metabolic health status. So I have individuals who are elderly, I have young, healthy, 18, 20-year-olds. And yeah, so it's going to be a really cool data set that we're going to gain a lot of information from. But then I've completed a training study where I looked at fasted versus fed interval training and looking at whether there's different adaptations to having carbohydrates prior to high intensity interval training or whether fasting amplifies our adaptations to training.
Well, that's really interesting stuff. In the interest of time, one, I want to thank you for appearing on my podcast. I think this is the kind of stuff I think that will generate a lot of conversation, and I appreciate the work you're doing. So I want to thank you for that.